Welcome everyone. This video is an introduction to object-oriented programming and user-defined classes. We've been working with objects all along in Python. Different objects help define different kinds of functionality and the way we can organize data. The object types that we're most familiar with are the built-in types. And those types, hopefully you can name many of these, and it might be a good little test to yourself to see how many you can name. But the types that are built in that we know are int, float, and string, list, tuple, set, and dict, none type, which is the none value, bool, which is true or false, and the file object has another name, but we know it as the file object. And these are the basic types that we would consider to be built in. There are a number of other types that Python provides, but they're much more specialized. And in addition to those types of objects, we have custom objects that were created by other developers, not connected to Python itself. For instance, in web scraping in Beautiful Soup, we have a soup object, BS4, otherwise known as Beautiful Soup. We have certain objects that allow us to negotiate all the tags within an HTML page. We have a soup object, which is really known as a Beautiful Soup object. We have a tag object, and there are a number of other objects that are related to that library. Those object types were created specifically to allow you to very easily work with the BS4 package. And there are other types that we may have worked with in the past as well, and ones that we'll work with in the future. In fact, many times when you decide to use a new kind of module, for example, pandas and matplotlib, which are two modules we'll be using toward the end of the course, anytime you do this, oftentimes, or most of the time, you'll be presented with a new object type to work with, or a series of types. Think of regular expressions. The regular expression search method can return what we call a match object, and this is an object that you can query with .group to find information that you want. In the slides, I show you a couple of examples. One is an existing example, the datetime object or the date object, and the time delta object that allow us to work with dates. And if you look closely at what's going on here, when I say date and I give it three names, I'm not calling a function really. What I'm doing is constructing a new kind of object. And here I'm doing the same thing with time delta. The date object represents a specific date, and the time delta object represents an interval, a time interval. And I'm able to use those objects together to produce, let's say, a new object or other value that allows us to calculate dates. We can look further into the datetime object, and I definitely recommend that you do that because it is the easy way to work with dates. But this is just an example to show you how an exotic object, I call it exotic if it's not built in, a special kind of object, an exotic object, an object that we didn't define, that Python didn't define, but was defined by the author of a library, gives us easy access to the functionality of those libraries. And again, think of the soup object, the tag object, think of the regular expression match object. These are objects that we've worked with that weren't part of built-in Python, but that were created by other people. And what we're going to do in this session is learn how to create our own object types. Don't worry if you're not quite sure how you're going to apply this. The main idea is that we're going to learn the mechanics of it and show how it works. And then gradually, by seeing how it works, you'll hopefully begin to appreciate exactly why there's such a powerful type of functionality for Python. And another example I have here, I actually made up my own object type, and I haven't even implemented it. But it's one that you might imagine provides an interface to doing something that some IT professionals have to do working with a server. Now, again, I didn't write this. I didn't actually create it. What I did instead was conceptualize how it would work and what sorts of methods I might work with this particular object, and then show you an example of how it could be used. Now, this could be easily implemented, and I'm sure that there's an object like it somewhere in the world. The idea is that I would create a new class called server. Now, again, this is imaginary, but I hope by looking at this example you can see how it would be used. The server object is supposed to represent a server. Blakey Serve would be the name of my server, let's say, some server that I'm working with. Now, what are the things that you can do with a server? You can restart the server. You can shut down the server. You can ping the server. I don't know if you're familiar with pinging, but pinging a server allows us to see that the server is alive, and also allows us to see how long it takes for a message to get to the server and back. We can also copy files up and down from a server. We could even issue remote procedure calls to a server. That's where we run a program remotely from a different server to a remote server. But regardless, the concept of working with a server is an important first step. The first idea is, what would a server object do? In other words, what I'm proposing with this server class is the idea that we could produce an object in Python that represents an actual external entity that we might want to work with. And we can create methods that when we call those methods from within Python, it would result in that thing being done to that server. Now, the pinging of a server is something you just have to learn the method involved. If I wanted to ping yahoo.com, for example, I can ping the server and it will tell me that the server's alive and that it took, it looks like 73 milliseconds on average, or 75 or 80 milliseconds to send a message, a very small message to the server and receive it back. This is why it's called pinging. You're sort of making a little ping noise and getting it reflected back. This is what the ping server is all about. This is just something you can do with a server. And in order to do it from Unix, and I think it's worked from Windows as well, is you issue the command ping and the name of the server. Now, when we look at it in this invented class, this imaginary class that we could easily implement, the idea would be that if I defined the server class, if I create my own server object type, and I allow the user to create an object based on a particular server name, that if they call the ping method on that object, it's going to result in a ping message being sent. And the same thing would be true of these other imagining methods: restarting a server, copying a file to a server or back, checking how long the server has been up. All of these things are commands that can be issued from the command line. But what I'm trying to accomplish with this server class is to give other users a simplified interface to some of the functionality of a server by defining it in Python and allowing calls to the methods to actually issue some of those internal commands that we might issue if we wanted to work with the server. In other words, it allows me to programmatically work with some external technology through the class. Now, this isn't the only thing that you do with classes. Operate external, let's say servers or other entities, but instead allows us to work with data in different ways, like the datetime class, or to work with reading a file in a particular way, like it does with the soup object and the tag object. That's part of the soup class and the tag class. And this is the purpose of object-oriented programming, for us to create functionality that we hide behind a simplified interface. We don't hide it really, but we place it behind a simplified interface that will allow any other user, including ourselves, to use this simplified interface to work with some external technology. Classes aren't required for you to get your job done, but they really, really help us organize our code and our way of thinking about our code. And that's the reason that we have classes and the reason for object-oriented programming. I'll just conclude this introduction by saying that object-oriented programming helps us handle complexity. This complexity is something that programmers have had to deal with for many years. Ever since the rise of greater and greater amounts of memory in our computers, our programs have gotten more and more complex. And the big problem with that, of course, is that it becomes increasingly difficult to write a good program that's not going to have bugs or problems. Object-oriented programming was created specifically to allow us to manage this complexity, basically by allowing us to create a concept behind functionality, a concept behind code that we might write, and to create a simplified interface, a simplified way of accessing that functionality that is completely what we say is encapsulated within the object, so that a little like a function, but much more useful than a function, it allows us to hide or encapsulate or sequester, to set aside functionality and data into this class and in this object without having that code interfere with the rest of our program. It's good for code reuse, code management, code conceptualization, and for managing complexity. And this is the reason we have objects. Now again, this may not be entirely clear to you until we begin using them. But let's now, in the next video, move on to the mechanics of creating and using classes.